In this video, I'm going to talk about how to resolve a vector into its x and y components. And as you can see by this little notation right here, this is an extremely important thing to know how to do. It forms the basis of all or most of two-dimensional motion problems, two-dimensional force problems. You need to know how to do this stuff in order to move on from here. All right, so you may not know this, but we've already been using this word, but what it means is this. The component is the word that you've heard already, and that's simply the projection of a vector onto a coordinate axis, the y-axis and the x-axis. In resolving a vector, what we're doing is we want to find the x component of that vector and the y component of that vector. Here's what I mean by that. We'll be given a vector that says, you shoot a ball from a cannon at 30 meters per second and it's at 45 degrees above the horizontal. Resolving a vector into its components is answering the question, how much of this motion is going straight in an x direction and how much of this motion is going in a y direction, because you may be able to tell that right now there's both going on. And in physics, it's important to solve two-dimensional problems in terms of x motion and y motion only. We cannot work with things that are in between x and y. This right now is neither x nor y. There's some x motion and some y motion that are contributing together to make this, and we want to find how much is in the x and how much is in the y. That's what we're doing when we're finding the x and y components. So to illustrate how to do that, I simply want to work this problem that's stated here. You travel 30 meters at an angle that is 25 degrees south of east, and let's resolve this vector into its components. All right, the first thing you do when you resolve the vector is you want to simply draw it. And let's think here. 25 degrees south of east. Well, if this is east, and I'm not going east, but I'm going on a route that is 25 degrees angled to the south of east. So my vector will look like this. And I'm going to draw this vector here. It's kind of exaggerated, I know, but I'm just making the point. I'm going to label the magnitude and the angle. The magnitude is 30 meters. The angle is 25 degrees. And after I do that, I want to draw the x and y components. And that may sound hard, but it's really not that big a deal. All you have to do is complete the triangle. This will be the hypotenuse of the triangle. There's your x component. X. And there's your y component. We've drawn the vector. We've drawn our components. We've labeled everything. Now we can move on to number 3. Very important. Don't forget about direction with all of this stuff. In terms of direction, when we draw the x and y component to start off with, we've got to be concerned about direction. These are not just lines that we draw. It's not the sides of a triangle. This is a vector. It has a direction. When we draw the x vector, for instance, there's two choices for direction. You can either be going to the right or you can be going to the left. Two choices. So we have to figure out, based on this vector, what direction this one is going. And by looking at this one, I know that it's clearly not going to the left. If anything, it's going to the right. So I'm going to draw my x vector pointing to the right. Same vein of thought with the y vector. I got two choices for its direction. One is up and one is down. And I make the choice based on what my vector that I was given is doing. This one's clearly not going up. It's going down more than anything. So I will draw the y vector down. Also, notice what I've just done. These are my two component vectors. Look back at your vector addition rules. The head of the first has to meet the tail of the second in the components. Guess what? It does. Head to tail. So we're good to go. Now I want to find the x component. I'm going to use trigonometry to do that. The x component, if this is my angle, the x component is the adjacent side, and the y component will be the opposite side. I have the angle, I want the adjacent side, and I have the hypotenuse. So I want to use a trig function that incorporates adjacent and hypotenuse. That's cosine. Cosine theta equals adjacent over hypotenuse. That's my equation. Now I'm going to substitute numbers in there. I happen to have the angle this time. the cosine of 25 degrees, my angle, equals the adjacent side, which I'm going to call x, that is now my x component, over the hypotenuse, which is 30. And now what we have here, don't let this trig function confuse you, because this trig function is just a number. And now we have a number over an understood 1, and you might be able to see now that you have a fraction equal to a fraction, in which case we need to cross multiply. And we end up from that getting 30 times the cosine of 25 equals the x component. And the beautiful thing about this part is now we can enter this directly into our calculator, just like it's shown, 30 cosine 25. No inverse function if you already know the angle. Hit enter. 27.2 is what I get. The x component of this vector is 27.2 meters is the unit. Now I'm concerned about direction. I already have the direction labeled, and it's east. That's my x component. Let's go to the y component. Y is the opposite side, and I know the hypotenuse. Let's make believe right now that we don't know the adjacent side. So I'm going to find a trig function that incorporates opposite and hypotenuse. That's sine. Sine theta is opposite over hypotenuse. Put in numbers. The sine of 25 equals y, my opposite side, over 30. Once again, over 1, fraction equal to a fraction. So I'm going to cross multiply, and I end up with 30 times the sine of 25. That's equal to my y component. Once again, I can enter that directly into my calculator. 30 sine 25, and there we go, 12.7. 12.7 is my y component. 12.7 meters is the units, and the direction is south. 27.2 meters east is the x component. 12.7 meters to the south. Those are my directions. Now, we did this the long way. I'm going to make it shorter on you real quick, because in this class at least, maybe not higher level physics classes, but in this one, every single time we want to find an x component, we do something. Notice that these two look the same, and you'll get the same every single time, provided you've drawn your picture correctly. So to find the x component, every time you do c times the cosine of theta, your angle. And to find the y component, you do c times the sine of theta, your angle. C here is going to refer to whatever our hypotenuse is. In this case, it was 30. So it's the value of our hypotenuse, 30, times the sine of the angle or the cosine of the angle. Okay? And the hypotenuse could be a velocity, which we'll use v to indicate. So in the coming weeks, you might hear me say v cosine theta or v sine theta. It could be a force. So you might hear me say f cosine theta or f sine theta, or this could also be a displacement, delta d. Okay? The reason why this is a shortcut is because you no longer have to do all this work. You can memorize these, and as soon as you see x component, you know f cosine theta or v cosine theta. As soon as you see y component, you can automatically know f sine theta or v sine theta. An easy way to memorize that, I think, is just to remember that y rhymes with sine. Y goes with sine, and then x goes with cosine. We don't use tangent if we already know the angle. You can, but you don't have to. Okay? This is the easiest way I think to do it. Okay? So that's how to resolve vectors into x and y components.